Hi there. In our last section, you learn about the equality of complex numbers, addition, subtraction, multiplication, and division of complex numbers. In this section, you are going to learn about power or exponent of I. So let's begin. Power or exponent of I. In order to understand the power or exponent of I, what we need to do first, we need to understand what is I means. So I is a symbol that used to represent square root of -1. So basically, if you know that we cannot find the square root of a negative number, or in other words, we can say that it is not possible to find the real root of a square root of negative number. So I represents that I is a number which is equal to square root of -1, and this is basically a complex number. So we can say that I square is equal to -1. Let's consider some situations to explore the exponent of I. So my first situation is I cube. So I cube can be written as I square times I, and as we know I square is equal to -1 from here times I. So -1 times I is -I. Now let's consider another exponent. So the next one is I to the power 4, which is equal to I square times I square, and I square is -1, so I will write -1 times -1, and -1 times -1 is +1, so I will write 1. So basically I to the power 4 is equal to 1. I to the power 5 is equal to I square times I, and I'm going to replace all the I squares by -1. So I will write -1 times -1 times I, and -1 times -1 is +1. So +1 times I is I, which is over here. In the same way, I to the power 6 is equal to I square times I square times I square, and I square is equal to -1, so I will write -1 times -1 times -1. So -1 times -1 is +1, and then +1 times -1 is -1, which is over here. Now I to the power 7 is equal to I square times I square times I square times I, and I am replacing all the I square by -1. Then I will write -1 times -1 times -1 times I, and after multiplication I will get -I. In the same way, I to the power 8 is equal to I square times I square times I square times I square. So basically I am multiplying I square 4 times, and each I square is equal to -1. So I will write -1 times -1 times -1 times -1. So -1 times -1 is positive, and then the last two negative ones are also be positive. So 1 times 1 is 1. Now let's consider some exponents with negative power. So the first one I would like to consider is I to the power -1. So I can write I to the power -1 as 1 over I. And what I'm going to do, I'm going to rationalize this. So what I will do, I will multiply numerator and denominator by I. So I will write 1 over I times I over I. 1 times I is I, which is over here. And then I times I is I square, which is over here. And as we know I square is equal to -1, so I will write I over -1. So I over -1 will be -I. I to the power -2 is basically equal to 1 over I square. And we know that I square is equal to -1, so I will write 1 over -1, which is equal to -1. In the same way, I to the power -3 is equal to 1 over I to the power 3, and I can write it as 1 over I squared times 1 over I. And 1 over I squared is basically -1, so I will write 1 over -1, and then 1 over I is basically -I from here. So I will write 1 over -1 times -I, and that is equal to I. Now let's consider one more. So I to the power -4 is equal to 1 over I to the power 4, and that is equal to 1 over I square times 1 over I square. Since I square is equal to -1, so I will write 1 over -1 times 1 over -1. And basically this multiplication is equal to 1. So if you look at all these exponents closely, you can see that we have a pattern that we can use to find a general rule for the exponent of I. So we can say that For any integer n, I to the power 4n is equal to 1, I to the power 4n plus 1 is equal to I to the power 4n plus 2 is equal to negative 1, and I to the power 4n plus 3 is equal to negative I. So basically, we have four general rules that we can use to find the exponent of I.